Hello and welcome to the quick discussion of Module 1 for the subject code BDS306B Python programming for data science. So the syllabus is like this. We'll be seeing an introduction to Python, elements of Python language, Python block structure, variables, assignment statements, data types, operations, simple input-output print statements, and formatting. So the textbook for the Module 1, Module 2 and Module 3 of this subject code is Python Programming by S. Sridhar, Indumati and Hariharan. So for this first module, you need to refer the chapter 3, and these are the sections that you need to refer. So let's start with the first part of Module 1. So let's first start with what is Python. Right, so Python is a programming language that's used for many different purposes. You can use it for web development, it's widely used for software development, it's widely used in data science for data analysis and machine learning, it's used for system scripting and automation. So Python language was developed by Guido van Rossum in the year 1991. So these are the features of the Python programming language. It's an open source language. It's high level language. It's an interpreted general purpose dynamic programming language. We will see why it's called dynamic in the next session, in the next slide. It's relatively easy to pick up and use. It has extensive set of libraries. Python is backed by large community of developers, and it's easy to use because of its easy to use comprehensive libraries. Python package index lists all the package libraries and can be downloaded as PyPI. It has a very good flexibility, means that you can easily add on and make the program highly customizable, and hence it's widely used in the complex scientific computation. It's a cross-platform language. It's a platform independent portable language, and hence the Python interpreter can easily incorporate C, C++ functions and other languages. The software quality is also very good. It has very good readability, coherence and quality, and has many advanced features like generators, comprehensions, and it's a versatile language. The Python data types is strongly and dynamically typed. So in the sense, we do not have to whenever we are declaring a variables, we do not have to specify the data types, unlike in C or C++. Though you just have to, you can directly use the variables without declaring it, and hence Python is called dynamically typed. It's embedded easily into any application and therefore provides a programmable interface. The Python programmers use the scripting to automate the daily tasks, server management, social media management, financial trading, automating software, etc. The developer productivity also increases because of the smaller size and simple style of coding in Python. It also runs very fast, and therefore you have very less code to maintain, to debug. It has less compilation steps and less linkage steps, and hence Python has a very rapid edit, test, debug cycle, and due to its lack of compilation step, it makes the development debugging much more efficient, and hence Python is beneficial for web scraping, websites creation, data analysis, GUI development, game development, and so on. So now Python, when we are seeing in the next sessions, we can see that mainly it will have two types of statements: simple statement and compound statement. Simple statement means where you have just one single line of statement performing a single simple task. Example, you can just create an expression, or any assignment statement is a simple statement. Now compound statement is actually a group of statements that will span multiple lines, and that controls the executions of other statements of that program. Example, looping statements, functions, they're all examples of compound statements. If, while, or when you are writing a function, they're all examples of compound statements. So this is an example of single line statement, because these are assignment statements. X is equal to 10, Y is equal to 20. These are simple statements. But next sessions you will see how to create looping conditions like while, or conditional statements like if, and how to create functions. So they're all compound statements. So let's see the difference between the Python 2.0 version and Python 3.0 version. 2.0 is actually the older version of Python, and the new and the updated version is 3.x. So the syntax, if you see a print statement, the syntax will be like this. You just have to give print and hello. But here when you're giving print statement in Python 3, you just have to give it within parentheses. You have to say print hello within parentheses because print is actually a function. In Python 2.x, it uses ASCII as default for string representation, but Python 3.x uses Unicode, that is UTF-8, to represent the strings. Because many foreign languages and more characters are also supported here. Python 2.x is not forward compatible, but Python 3.x is compatible compared with 2.x. The division in Python 2.x is little awkward. For example, if you just divide 7 by 2, you will actually just get 3. You will not get the value after the decimal point. But the same thing when performed in 3.x version, you will get the answer as 3.5. 7 by 2, it gives 3.5. Hence the calculations are more accurate. So coming to the elements of Python language, so a set of valid characters that Python language can recognize, we call it as character set of the language. So Python can recognize alphabets. It uses all these characters, alphabets, uppercase, lowercase. You can use all the special characters like this. Token, we have concept of token. We will see what is token. It is actually the smallest lexical unit of a program. There are different types of tokens. We will see in the next few slides. Identifiers, keywords, literals, punctuations, and tokens are actually separated by space, tab, or carriage returns. And so these are all the set of characters Python language has. So Python has language has alphabet, special characters, tokens like identifiers, keywords, literals, punctuators, or delimiters. We'll be seeing all this in the next sessions. So let's first see what is a token. See, as I said, token is actually the smallest lexical unit of a program. Okay. There are different types of tokens like identifiers, keywords, literals, punctuations. See, for V2 exam, this is one of the very common question which is asked, what is token, and explain the different types of tokens. So you need to write this is the smallest lexical unit of a program, but these are the different types of tokens and you have to explain each one of them. Okay, so let's first go to identifiers. So what are identifiers? Identifiers are nothing but the names that represent the programmable entity in a Python. For example, if I say I is equal to 0, 0 is a value which will be assigned to I. I is the variable. Now variable is a named memory location where the values are stored. Right? So whatever we have, all the objects, all the functions, all the variables, they will all have name. So these names are actually called as identifiers. Okay? So when you are writing your program, you are declaring I is equal to 5. So I is actually a variable and the name which you are giving to it is called as an identifier. You declare a function. So let's say the function name is calculation. Now calculation is the name of the function and that's actually an identifier. It's a name which is given to a function and that's an identifier. Now there are certain rules that governs like how you can give these names. Okay, how identifiers can be given names. There are certain rules. The first rule is every identifier, it must start with a letter. That means you must have only alphabetical characters, or it can start with underscore. That is also allowed. Now this letter and underscore can next be followed by, you can follow it by letters, you can follow it by digits or underscores. And remember, you cannot have an identifier with space. I cannot have a variable called as I space J. I cannot have like that. Okay, identifiers have to be continuous. You cannot have a space in the identifier. And very important is it is case sensitive. Identifiers are case sensitive. So if I write Celsius is equal to 5 with all small letters, it is different from this, all capital letters, or it is different from this. See, all these three are actually different. Though the meaning is same, they're all different because it is case sensitive. So programmers, very important is they can choose any name based upon this rule, but very important is when you're creating variables, you should give, or functions, you should give some meaningful names. So that was about identifiers. Let's now go into keywords. Now what are keywords? These are reserved words or keywords, and they are reserved by Python for some reason. So Python will have some inbuilt functions. So that will also be a keyword. Like for example, print function. Print is a keyword. I cannot use print as my variable. Okay, so Python does not allow the programs to use these functions liberally. See, for example, print is a function. I cannot make any variation. I cannot create a function with the same name. It will be blocked. It will give an error. So it's better to avoid such names, like, which can cause disruption to during your execution. Now, how will you come to know which are the keywords? Very easy. You just go to your ideally screen wherever you are executing your Python program. You can follow. You can use Anaconda prompt. You can use ideally screen. You can use Jupyter Notebook, whichever you are using. For installation of Python, I'll give the link in the description box. So once you have installed, as you're studying, try to execute to make it more meaningful. So question is, how do I identify which is the keyword? So what you have to type is import keyword and then give the statements keyword.kwlist. So I'll be showing now this in the Jupyter Notebook. This is my Jupyter Notebook. I'll open a new script. Okay, so what I'll do is import keyword. Okay, and then next what I say is keyword .kwlist. Okay, now execute. How to execute? Shift enter, shift enter. See, so when I said that, so these are all the list of keywords you are getting here. See how many are there. You can also get a length. Just call the length function. See, length is also a function of Python. See, there are 33 keywords that it has displayed. So which are they? Let's just see it again. There are 33 keywords which are displayed here. Okay, so these are some of the keywords of Python programming language which you can view by typing this in your editor. Now, coming to the next identifier, that is literals. Now, what are literals? Literals are constant values. Okay, so it is one way of specifying a data value. What are constants? Now, these constants are the values that can never change during your program executions. So basically, what's the definition of literal? Literals are constants. Example 18, 7.8. You can also have a string within quotes that can also be a constant. So literal in Python, it can be a number, it can be a text, or it can be other fixed data. Now strings, if you are using, you have to enclose it between quotes. You can either have single quotes or double quotes or even triple quotes. So anything enclosed between quotes will be identified as a string. So what are the different types of literals that you can have? We have three types of literals: string literals, numeric literals, and Boolean literals. String literals, what are strings? They are nothing but set of characters. You can also have spaces, you can have special characters, even keywords. I said you cannot use keywords on your programmer cannot use the keyword, but if it is enclosed within quotes, then the interpreter, Python interpreter, will assume that it's just a string. It will not take it as a keyword. Okay, so spaces, special characters, but avoid such things. It's better to avoid. So spaces, special characters, keywords within quotes are treated as literals. It is a string literal. Now, what are numeric literals? Python supports three types of numeric literals. Python 3 version, three types of numeric literals, that is integer, float, and complex. So you can have integer numbers like this, 23 without any decimal point. You can have positive and negative numbers. Floating point numbers, where you can have positive and negative numbers, but numbers with decimal points, that is fractional, 23.233, something like this. You can also have complex numbers like 3 plus 7j, where 3 is the real part and 7 is the imaginary part. And the third type of literal is Boolean literals, which will have just two possible values, false or true. Okay, we will be seeing about these things in the next few slides. So this was about literals. To quickly, just to remember, literals are nothing but constants. You can have string literals, numeric literals, and Boolean literals. Now this is something that you'll be seeing always, or I'll be telling you in the next few sessions: punctuators or delimiters. So what are these? They serve as separator of values. Basically, when you want to separate certain things, which you'll be seeing next. When I'm printing something, I'm printing a list, I want to separate the values with a comma. I want to separate the values of a list with a colon. I want to separate the values of a list with a slash. Then you specify the delimiter. So if you want to separate with colon, you give colon. If you want to separate the values with slash, you give a slash. So basically, delimiters are separators of values. Okay, we will be seeing this. They're also called as punctuators. Now, coming to the Python block structure, when we are executing, we will see that there will be a lot of errors that will happen. Mainly the reason is when you are not representing your program block structures correctly. This you always have to remember. Indentation plays a very important role in Python. See, in C what happens is, even if you indentation is a very good style of coding. When you're writing in C or in Python, you should have indentation. But in C, if you don't indent, it will not give you an error, because the block of statements, if you write within curly brackets, then it will understand. Okay, so in C we use curly braces to represent the block of statements, but in Python we do not have these curly brackets. We use the indentation style of coding in Python. So the set of statements, we call it as block. So if you see this diagram, if we have your block 1, so that means I have some set of statements which are over here. So block 2, this is another set of statements which is under block 1, so you have to give 1 tab space. Then I have some more set of statements which are under block 2, so you have to give 2 tab space. Again I have block 2 statements, so again I give 1 tab space. Again I have block 1 statement, so there is no tab space. So that's why indentation, Python has an indentation way of styling. It refers to the white space. Indentation means white space. It can be a space or it can be a tab space. Because Python does not use curly brackets to represent the block statements, we use only indentation style. So this is actually not just a style, we can say it's a requirement. So that means if you don't follow the indentation error, then you will see there is an indentation error in your program. So for example, if you see this program here, see I've declared a variable total is equal to 0. I've started a for loop for I in range of 10. So that means I is, and you have to follow it by colon. So I starts from 0 and it will go up to 9. I is going to have 10 possible values. So under for loop I have a statement called as total is equal to total plus 1. So you have to give a space here or a tab space. We do not use curly brackets like in C. And then when you are giving print total, I want to print the total after the looping is stopped. So that means my print now will be at the same, it will start from the same line where for started. There will be no indentation. So this is what we call, this is one block, this is another block, and this is another block, and this is another block. So this is called as Python block structure. Now coming to the next part, comments. So how do you give comments in Python? See, why do we give comments? To make the code more meaningful and context. Whenever you're writing, even in your examination, remember to write the comments. Only then your program is meaningful. If you just write your program without any comments, the person who is correcting your paper will not understand what you have written in your program. Always you should write meaningful comments to make your code more readable. So that's why comments are written, to make the code more readable, and it improves the readability by explaining the logic of the code. So how do you write comments? A single line comment will be, this is the sign, we call it as a pound sign. This is the sign for single line. So, and you can place comments anywhere in the code. There's no need that it has to be in the beginning or before any line. You can put it anywhere, and Python interpreter will ignore the comments. So whenever the Python interpreter comes across this pound sign, it will immediately ignore everything after that. It will not execute that. So there are three types of comments: block comment, inline comment, and multi-line comment. So block comment means, see, I am giving multiple lines. See, this is a comment here, this is a comment, this is a comment, because I'm starting it with dash. So I can have multiple lines, and you can see each one is starting with an hash, and this is a block comment because this is one block, this is another block, this is a block. Again, here you have block styling. Why we have done this? To make the code more readable, that's all. Okay, even comments are following the block styling. There is no space here, but there is one tab space here, just to make it more structured. Your program should look more structured and more readable. For that reason, you have block comments. Now, what is an inline comment? I can have comment everywhere, even after writing a code. See here, we have written a is equal to 10. After that, I am writing the comment that a is initialized to 10. Here I am initializing b is equal to 10. After that I am writing the comment. So what happens? Python interpreter, first it will initialize b is equal to 10, and when it sees this pound sign or the hash sign, it will neglect everything after that, because after that everything is taken as a comment. So this is called as inline comment. So where you have your code and after that you are giving your comment. And we also have multi-line comments. See, I want to enclose all of this within a comment. If I go on writing the pound sign for everything here, that can be time consuming. So in such case, we use triple quotation marks. Okay, something like this. This is called as a multi-line comment. See, I want to enclose all these lines of statements within a comment. So what I do is triple quotation marks. I have triple quotes here, triple quotes here. So that means everything inside this will be taken as a comment. So I can show you show this in the Jupyter notebook. Okay, so let's say I have multiple, this is Python programming tutorials. Okay, now I want to enclose all these things within a comment. I don't want to give single line because that will be time consuming, right? For every line, if I write hashtag or this hash sign or the pound sign, that can be time consuming. So what you do is just give triple quotes. 1, 2, 3. Similarly, give triple quotes even here. You have to close it. Okay, so now what happens is when I execute, okay, then I'll write here a is equal to 10, something I just want to give. Problem with the quotes. So when I execute this, it should take it as a comment. See, okay, see, when I enclosed 3 quotes here, 3 quotes here, it is not printed. Okay, but when I say what is A, that gets printed. Okay, it's not giving any error for any of this. That means all of these are taken as a comments. Anything between these quotes are taken as comments. Okay, so that was about the multi-line comments. So 3 types of comments: block, inline, and multi-line comment. Now coming to variables. What is a variable? So variable is basically a container where the value, so when I say in my program here, I said A is equal to 5, A is equal to 10. So what is this? A is actually a variable. So variable is actually a container where the values will be contained, and it can be changed during the execution. And one thing always remember is, where I will be telling in all the sessions, object, object, object. In Python, everything is an object. Okay, variable is also an object. Okay, so there are some rules when you're forming your variables. The variables can be of any length. Okay, the variables are case sensitive, which I told you. Python is case sensitive language. Small a is different from capital A. And when you're declaring your variable, it can start with character. You can follow it by characters. You can follow it by digit or underscore. And you can, inside your variable, you cannot have spaces, you cannot have dashes, you cannot have punctuation marks or quotes. You cannot have these things as your variable names, in your variable names. And keywords are not allowed. See, I said if is a keyword, right? So if I say if is equal to 100, it will give you an error. Okay, I cannot have if, I can just say I, because if is a keyword. Okay, so coming to this, just give some what you are seeing here is, can I have y as a variable name? Yes, it's valid. Can I have x1 as a variable name? Yes, it's valid. Can I have id underscore number? Yes, it's valid, because it starts with an alphabet and underscore is in between. That doesn't matter. Can I have while? Yes, while is actually a keyword, but still it is allowing, because I said Python is case sensitive. The keyword while, in keyword while, w starts with a small letter. Okay, so here this variable name while is starting with a capital letter, and therefore it's valid. But to avoid such confusions, avoid such names. Okay, avoid such variable names. Can I have a string as a variable name? No, it is not allowed. It's invalid. Can I start my variable name with a number? No, it's invalid. It's not allowed. Can I have spaces in my variable names? I can suppose, can I have workspace? Yes, no, it's not allowed. Can I have keyword as a variable name? It's invalid. Can I have special symbols? Like here you can see ID exclamatory mark. No, this is not allowed. You cannot have special characters in your variables. So these are some of the rules for variable names. Now coming to the next one, assignment statement. What you just now saw in the Jupyter notebook where I said a is equal to 3, it is actually an assignment statement. So what is assignment statement? It assigns the value on the right hand side to the left hand side and expressions. Okay, so an expression can be a literal, it can be have some calculations in it, you can also have a function call in your expression, or it can be a combination for all. So as I said, x is equal to 3 is a assignment statement. Value 3 is assigned to the variable or to the identifier x. Now here x is called as a L value. Okay, that is, it can be capital L or small l. We call it as L value. So what are L values? Even such things are asked for 1 marks. Okay, L values are objects to which the value or the expression is assigned. Okay, so as I said, in Python everything is an object. So L value is an object to which a value, or you can also give an expression to this x. So L values can appear on, it can appear on both the sides. For example, here I have written here x is equal to x plus y. X is both on the, x is on the left hand side as well as on the right hand side. Even that is possible. But 5, it cannot appear on the left hand side. That's a strict rule. So 5 is only a R value. Okay, you can only have it on the right hand side, you cannot have it on the left hand side. That's why 5 is called as a R value. So in this example, x is a L value. L values can appear on left hand side as well as right hand side. But R values, 5 is a R value. R values can only occur on the right hand side. And what is the syntax for assignment statement? It's like this. You have the expression which is on the right hand side, and you have the variable on the left hand side. So this is the syntax of the assignment statement. Now you also have something called as multiple or simultaneous assignments. So what is this? It allows initialization of more than one variable at the same time, and you can also do swapping is done using this simultaneous assignments. See this first line of code. What I have done here, I said x comma y is equal to 10 comma 20. So when I execute this line of code, x will be assigned with 10, y will be assigned with 20. So that means what? This is multiple assignment. You can have multiple assignment in one single line. And you can also do swapping. So what I've done here, x comma y is equal to y comma x. So what I did, I swapped the content. Okay, so this is called as swapping. So if you go to Jupyter notebook, I'll just show this here quickly. Right, instead of saying x is equal to 10, a is equal to, or let's say x is equal to 10, y is equal to 20, I can just put it in one line like this. So when I execute this and I try to see what's there in x and what's there in y, you can see x is 10 and y is 20. I can easily do swapping in just one single line. So when I execute this, now when I see what is there in x and what's there in y, see it has swapped. And now x is 20 and y is 10. The value has got swapped. Okay, so that is called as multiple assignment and also simultaneous assignments, and even swapping is done using simultaneous assignment. And what is the state diagram? This is the state diagram for x is equal to 3. I have x is one state and 3 is another state. And this is the state diagram for reassignment. So initially I said x is equal to 3. So x is actually, there should be an arrow mark here, x is actually pointing to 3. So x is actually a variable, it's an identifier. It will be allocated a place in the memory location, and that memory location is actually fixed. Okay, now if I do reassignment, initially I said x is equal to 3. Now when I say x is equal to 8, initially x was containing 3 and now it will point to 8. Okay, so now x will point to 8. It will have a different value. So there are 3 states here now, x, 3 and 8. Now x is pointing to this. So this we call it as a state diagram. Now coming to the next thing, when I was talking about features of Python programming language, it is a dynamic type programming language. So what do I mean? That means most of the other languages, if you have already know C, whenever I was creating, when I cannot directly say x is equal to 3, I have to say int x before that. So every variable has to be declared in C language or C++. So that means it's a static typing language. C is a static typing language, but Python does not require initialization. You do not need to declare, sorry, the Python you do not need to declare the variables that it belongs to which data type. So that's why Python is called as a dynamically typed language. Okay, so Python is dynamically typed language because it does not require variables to be declared. So for example, I can just say x is equal to hello, and indirect it will itself handle and make it, since hello is a string, it will itself declare it as a string. If I say x is equal to 5, the Python interpreter itself will declare the x as a integer. Okay, you do not have to declare the data type. Hence, Python is called as a dynamic type checking language. Now, namespaces. Now, Python interpreter uses a unique structure called as namespace, where it maintains the list of the names and their associated values. So each name, for example, will be having a value, or name is alias for a value. So Python updates the names as well as the value during the course of execution. So it updates the list when a new variable is created. It deletes it. It is deleted in the namespace when variables are deleted. So what do I mean? So when I just created a variable called as I is equal to 5, what happened when I did this assignment? A variable called as I got created, and there is some concept of namespace where structuring all the variables which are declared along with their associated values will be stored. So later on, let's say I delete this variable, so then it will also be deleted from the namespace. So that's why we say, what is namespace? It is Python interpreter uses a unique structure called namespace, where all these list of all these names and their values will be stored. Now coming to the objects, I was saying you already that in Python everything is an object. So now let's study a little bit about Python objects. So in Python all are objects. For example, variable is an object, function is an object, even value is an object. Okay, when I say x is equal to 3, x is an object, 3 is also an object. So an object is basically linked with three concepts: identity, 0 or more names, and a set of attributes. Coming to the identity of the object. See, when an object is created, naturally it has to be given a memory address, right? So when I say x is equal to 3, a memory location should be allocated for this variable. So how do I know what is the memory address? Where in the memory, where is the address? See, for example, I am staying at a particular place in India. So there is an address for it, right? So if anybody has to meet me, they have to access me through this address, or you can contact me through my email ID, right? So that is nothing but the identity, my identity. So similarly, any object in Python will be stored in the memory address. And how do you access that object? Through the memory address. Now who is storing this? Identity. Identity will refer to the memory address, and once it is put in a memory address, you cannot change it, right? Where initially when you create the variable itself, a memory address will be allocated, and that is permanent. So when an object is created, so it receives a unique identification number naturally, right? Every variable will be, you can just store one variable at one location. So it's a unique identification number. Okay, so Python function gets the memory address which is allocated to the object. So how do you find out the memory address? There is a function for this which we call it as ID function. Now this is a built-in function. Suppose when I say I is equal to I plus 7, I want to see where in the memory address it is stored, then you just say ID of I. So let's go to the Jupyter Notebook and let's see. See, I have created a variable here called as Y. Now I want to know where it is. So I just say ID of Y. Let's also see the location of X. See what I'm trying? I'm trying to see what is the memory location at which X and Y are stored. Okay, let me give it in a... Okay, so you can see that this is the location at which the variable Y is located, and this is the location at which memory address at which X is located. See, each has to be each is different, right? It's a unique number. This is different and this is different, right? So that it's a unique identification for your object. Now coming to the name. Name is binding to a value. So values, if you want to manipulate, you have to use that variable name. See, I said I is equal to 5. Now I want to change this value. I have to access it through this variable I. Right? So name is actually bound to the value using the assignment operator, and names are very handy. See, when I create a function, how do I access a function? How do I make changes in the function? Through the name of that function. See, somebody wants to contact me. How do they contact me? Through my name, right? So every name, so similarly here, name is bound to a value. You want to change that value, you have to access it through its name. And one thing is, a value can have multiple names, right? I said x is equal to 10 and y is equal to x. So 10 is stored in the variable x as well as 10 is stored in the variable y. So values can have multiple names. Now coming to the next one. Now attribute. What is attribute? It is a set of properties of an object. So here I said x is equal to 3 and y is equal to 3. Now x will have some properties, y will have some properties, right? Properties in the sense, what is the data type of x, right? What operations are happening in this. So if you want to know the properties of a variable, then that we call it as attributes. So attributes means properties of that object. It can be the data type, it can be the operator or the operations that you're doing, the identification way that variable is. So all these are properties of that variable. So that's nothing but attribute. So quickly revise Python objects. There are 3 points here. Identity, where basically you can access identity using the ID function. Names, where name is bound to a value. Attributes, which refers to the properties of an object. It can be the data type, it can be the operation, it can be the ID, even the ID or the memory address where it is stored. Now coming to the next two things, two types. Python will support two types of objects here, which we'll be seeing always, immutable and mutable. So immutable means a variable, it does not allow the value to be changed, right? Once the variable is created, you cannot change its value. So then we call that this object is immutable. So please remember this very important concept. Once a variable is created, if you cannot change it, we say that object is immutable. Now which are the immutable objects in Python? Int, string, these are all immutable objects. Float, bool, strings, tuples. We will see tuples in the next session. So tuples are immutable. That means once you create your tuple, you cannot change it, change the values in it. What are mutable? Means even after creating, you can change it. It allows changes after they are created and assigned. You create a variable, create this object, you assign it. After that again you can change. So which are the mutable objects? List, dictionaries and sets. So you'll be seeing this in the next session. List, dictionary and sets are mutable. They can be changed. So immutable means can't change. Mutable means can be changed. Now coming to the data types in Python. Now data type indicates what value a variable can hold. Okay, can it hold an integer value? Can it hold a floating point value? Can it hold a complex number? Can it hold a string? Can it hold a boolean? So data type basically will tell what values a variable can hold. And so Python will support, these are the classifications of data types. The basic data types we will see now: integers, floating point numbers, complex numbers, boolean types, none type. So these are the 5 basic data types. And if this is very important to write this diagram, this will also carry some 2 marks. So data types are classified into numbers, boolean, none, sequence data type, set of rows and set, mapping type. So under sequence you have strings, you have list, you have tuples. Under mapping type you have dictionary. Okay, we'll see each one of them. So coming to the first one, very important to write this chart. Now coming to the first one, integer data type. Integer data type, we call this as a primary data type. It is a whole number. That means you will not have decimal point here. Integers can be positive, it can be negative. So there are different types of integers in Python: decimal integers, octal integers, hexadecimal integers. Decimal integers will have a base of 10. Example, if I just write 45 minus 96 128, by default it is base is 10. Octal integers, if you want to, the base here is 8. As I said, octal base is 8. So if you want to create an octal number, you have to specify, okay, this is an octal number, because octal numbers can only have values between 0 to 7. So initially when you write a octal number, you have to have a prefix with 0 followed by a big O or a small o. Okay, so how do you represent octal integers? Prefix it with a 0, and then after that you should write a big O or a small o, like this: 0 followed by a big O or a small o. Hexadecimal integers, the base is 16. It can have values from 0 to 9 and A, B, C, D, E, F. Okay, so these are the values of hexadecimal integers. The base is 16, so the prefix here is 0x. Okay, 0 followed by a capital X or 0 followed by a small x. So if you are writing a hexadecimal number, for example, you have to write 0x, maybe AF. 0x9a. So they're all hexadecimal. So how do you identify it's a hexadecimal integer? By seeing the prefix. Okay, decimal numbers will not have any prefix. Octal will have the prefix as 0, capital O or small o. Hexadecimal will have the prefix as 0, capital X or small x. Now coming to the length, integers can be of any length. It is only limited by physical memory. Okay, next, floating point numbers. Floating point numbers are nothing but fractional numbers with decimal point. Now this can also be positive or negative. So here I will have 14.36, 14.333, like that. Okay, so these are the floating point numbers. You can have positive or negative. It will only have fractional numbers. That means there will be a decimal point. Now here also size is unlimited. It only depends upon the range of the machine. Now how do you find the data type? To find the data type of any variable, any value, you can easily do. Just type and within that you write the value name or the variable name. You can see the Python interpreter will tell what is a data type, because as I said, it's a dynamic programming language. We do not declare it. So seeing the value, Python only will indicate the data type, will give the data type to it. Now coming to the complex numbers. Now complex numbers will have, as we know, it will have two parts, right? One real part and imaginary part. So this is an example of a complex number, 3 plus 8j, where 3 is the real part and 8 is the imaginary part. So how do you represent it? There are different ways of creating complex numbers. If you say complex 3, 4, it will only give the output like this, where it will take 3 as the real number and 4 as the imaginary number. You can also write it in the complex format only. So you can say C is equal to 3 plus 8j. Now if I want to access a real number of the complex number, you just say C dot real and C dot imaginary. Now let's go to the Jupyter notebook to see this immediately. Let's first declare an integer. Let's say I have created an integer minus 33 like this. Shift enter. Now if I want to see the data type of this, I just say type of I. See, it gives the integer as data type as int. I can want to create a octal number. So how do you create an octal number? 0, you can have big O or small o after this, and then let's say 16. So if I give type of I, see, it is giving as int. It will not say octal int, hexadecimal int, but it will just give as int. Let's say I want to create a hexadecimal number, then 0 followed by x, and let's say I give ff, because hexadecimal can have value from 0 to 9 and ABCDEF. If I execute this, if I say type of, okay, it's not defined. Let's say 6f. Okay, we'll see about this later. So if I want to see the type of I, it is saying as int. So now let's see about complex numbers. How do you declare a complex number? Suppose the name of the variable is C1. C1 is equal to, if I say 3 plus 8j. See, if I say C1, see, this is a C complex, and if you see the type C1, so this is a complex number. How do you declare a floating point number? If I say some number with floating point number, if I say the type of F1, see, it gives float. Okay, so here I have shown you how to declare integer numbers, floating point numbers, and complex numbers. Now let's see the Boolean type. See, Boolean, it has a data type called as, Boolean types will have a data type called as bool. So Boolean types will have only two values. Either it will have true or false, or it will say 0 or 1. 0 corresponds to false, 1 corresponds to true. So I can create a variable and assign it a Boolean value. So let's say like this. I will say bool2 is equal to, when you say true, T should be capital. Okay. So if I try to see what's there in this, see, true. And if you see the type of this bool2, see, okay, type. See, right? What is the data type of bool2? Bool. As I said, bool, it will have the data type. Boolean values will have Boolean types have a data type called as bool. The data type of this is only bool. I can also say bool of 1. Okay, so when I say bool 1, it's nothing but 0. If I say bool 0 here, it means false. So that means 1 is true, 0 is false. You can also check. I want to check, right? This is a string. What is a string? If I put anything within a, like this, within quotes, it's a string. So if I execute this, it should give true because it is enclosed between quotes. So it gives a value as true. Now coming to the last one, 9, none type. There is also a data type called as none. So in other languages we call it as null. Similarly in programming in Python we call it as none. So none means what? No value, not even 0. So this is a special data type where the variable will have no value. Okay, so if you go and check in, if you check here, what's the type of none? Okay, should be small letter. What's the type of none? See, it is giving the data type is none type. So it's actually a very good MCQ question. None is the only one which is of the type data type. Okay, so this is the only one, this is the only value in your data type none. Right, this data type will have only one value, that is none. So none is the only type of data type, none type we call it as. Okay, so that's it. So this was about the basic data types: integers, floating point numbers, complex numbers, boolean types, and none type. Now there's one more concept called as collection data types. What we saw before was basic data types. Now we'll see collection data types. So there are two main kinds of collection data types: sequence and mapping. So sequence is an ordered collection of values. Okay, so the sequence data types are strings, tuples, and list. So what is sequence? Means you will have some ordered collection of values. So string is actually a sequence of characters, right? So that is also a collection data type. It's a sequence data type. List, I will be giving the description box, in the description box where I'll be discussing more in detail about list and tuples. That would be given in the description box. So list is a sequence of values. So if I have created a sequence of values here, right? List is always enclosed between square brackets. I can have integers in that, floating point numbers, integers, and strings inside this. Now tuple is also having a sequence of values like list, but it is, the difference is it's enclosed within parentheses. And main difference between list and tuple, please always remember, tuple is immutable. That means it cannot be changed. Once it is created, you cannot change the value in it. So this is a tuple. So let's see this in detail. So what is string? String is a sequence collection of data types. It has a collection of characters. So anything you enclose within quotes, single quotes or double quotes, it will be taken as a string. Lion, even 14 is taken as a string because I enclose it within single quotes. Now strings can contain not only just alphabets, it can have numbers, it can even have punctuations, it can have special unprintable characters. I can also have special characters inside that. Anything, even keyword, in fact, if it is enclosed within these quotes, the quotes can be single, it can be double, or it can be triple, it will be taken as a string. See, I'll just show that here. So if I say A is equal to, see, within this I will give a keyword called as print. Print is a keyword. See, it is not giving any error, right? So anything you enclose within single quotes, double quotes, or triple quotes, it will take as a string. You can have alphabets, numbers, even special characters, even keywords there. Now some of the string operations are concatenation. Concatenation is a process where you're combining two strings. Okay, so for example here, what I will do is I will just demonstrate concatenation. Hello plus world. Now I'll give print of this. So what I did here, I am trying to concatenate string hello with world. How did I concatenate? With a plus operator. So when I execute, see what happened. The two strings got concatenated because this plus here, this is an example of string concatenation. I can do string repetition. See, I want to repeat this 5 times. How do I do? I'll just put this within one more braces. Multiply that with 5. Okay, and one more parenthesis here is needed. Okay, now let's okay, so what I've done is hello word, I'm multiplying it with 5. So what happens? This will do repetition. Okay, let's give it directly as hello word. I'll remove this. Okay, this is a mistake. Print, right? I have to give the parenthesis here. See, hello word is now printed 5 times. Okay, so this is called as repetition. If you want to repeat a string, just multiply with how many times you want to repeat. Slicing, I can extract a part of the slice. See, here I said A is equal to print, right? So I just want to extract these two. So how do? You do it by slicing. You have to give the number. See, a of, if I say 1:3, see what is coming, ri. So this is coming. So basically the first character will start from 0. If I want the first 3, see, pri is coming. So that means 0, 1, 2. This is a concept of indexing. The first character will start from 0, then 1, 2, 3, 4. But it 0, 1, 2, 3. 3 is actually n, but n will not come here. It will be always 1 minus. In Python, this is how slicing is done. Remember this. 0 to 3, if I give like this, it will start from 0. It will go up to 2. It will not go up to 3. That's the concept of slicing in Python. Next, length. If you want to find the length, just very easy. Just call the length function, length of a. Okay, that basically giving the number of characters in this, right? print is actually 5 characters, so it gave the length of the string. Next, you want to delete a string. How do you do it? So I want to delete this. Just give del of a. Right now, if I try to type a, it will say name a is not defined. So I have deleted the string. So these are the different string operations: concatenation, repetition, slicing, length, deletion. It can be asked in the exam. So you have to write this table and write what exactly each one means, and then write examples for each one. Now coming to list. List is basically a set of items or elements. So how do you create a list? You put it within square brackets and separate each values or elements of the list with commas. List can contain integers, it can contain strings, it can contain floating point numbers. And here also indexing will be the same thing. The first element will start from the index 0, then 1, 2, 3. It also has a negative index concept. If you are doing indexing from the right hand side, then this will be -1, -2, -3, -4. I'll give in the description first for a complete detailed video of list in the description box. So and one thing is, you have to, very important point you have to remember is, lists are mutable, as the items can be changed. Mutable means it can be changed. So some of the operations that you can do in lists are adding, combining, insertion and deletion. I'll give the link of all this in the description box. Now coming to tuples. See, tuples, the same thing like lists, but it is enclosed within parentheses, and it is lists are mutable but tuples are immutable. Okay, remember this, tuples are like list, but it is immutable. That means you cannot change the size or elements of the tuple. It is enclosed within round brackets. Okay, and if you have a tuple with only one single element, we call it as a singleton. And a tuple can contain another tuple. And here also it supports all these features: indexing, slicing, insertion, deletion. And the only thing is, you cannot change the elements of a tuple. So this also descriptive video, of detailed video, I'm giving in the description box. Now coming to the, so that was for today's session. So the next session we will continue with module 1, again the next topics of module 1. So any doubts, any comments, any queries, please write to me in the comment box. Thank you so much.